So I guess I get to warn you all, you're now being recorded. All right, so when we talk about a theorem, it's a statement that can be proven. But once you've proven it, then you can use that as reason in other proofs. So right now, like I said, the only thing you really should have is the structure of a two-column proof. And so far we've done it a few times. Unless you're super good at drawing straight lines, go ahead and always use a straight edge. And the structure is always the same. I'm actually going to show you some different kinds, but right now on the left, we're always going to write our statements, and on the right, we're always going to write our reasons. And sometimes students say to me, well, how do I know if I'm done? Or how do I know where to start? Or how do I know what to put in the middle? So I'm going to give you some guidelines. And over here, I hope you have room for it. And I want you to add rows to your proof if any of these three things happen. First of all, if it was given to you. And you can get the information two ways. You can get them in the directions where you would read them, or you can also get them in the diagram. Okay, so that's usually where you start. The second way, if it is a vocabulary term or a definition, that gives you a lot of information. Another thing that you will be adding is a property, like reflexive, symmetric, and transitive. A third one would be a postulate or an axiom, which we know are just accepted to be proved. And then D, the last one, is a theorem. And we're going to be, this is sort of important, we're going to be doing lots and lots of theorems throughout the year. So that's why I put a little star by that one. But then once you prove it, you can use it for anything else. So that's the nice thing about that. And then third, and this follows along with the argument, if it is something you can conclude from prior statements. I'll give you an example of that. So say I find out, or I'm given the fact that two angles are congruent. So I'd start there, but then I would add, the next one would be that the measurements of the angles are congruent. So because I got that, I could say the next one. And then finally, I'm not going to put anything more here, but the last thing is, how do you know when you're done? Okay, so you're done when your last line matches the prove statement. When it says exactly what it says, then you're going to be proven. So did I go slow enough for you all to write that down? Josh, you still with us? Okay. Because what I'll do often is I'll just like use previous notes from the page before, and then I'll just go super fast. So I wanted to give you time to write that down. Now this one was in the examples from yesterday, so I'm not going to fill that out. These two, they're both angles, but we're going to write them down. And this is why I wanted you to use the colors. So what we're going to do is like color code stuff and try to figure out stuff that way. And I'm going to start by doing my, I call it a T-chart. It's not really a T-chart, but I like to always start with my straight lines because it's always the same way. Here's my statements, and here's my reasons. Now, I'm going to read the problem because that's what I can do next. Okay, so angle 1 is a complement of angle 2. So that's a vocabulary word. What do I get with the word complement? Anybody just go ahead and unmute yourself and tell me, what does complement give you?
Um, 180 degrees.
Thank you, Zaina, for volunteering. And you're close. What you got was supplement. So complement is the small cute one. Instead of 180, how many degrees do we get?
90 degrees, sorry.
Yeah. So we get two angles that add together to give you 90. Thank you for speaking. So this is going to give us two angles that add up to 90 degrees. Okay. It also gives us, so 1 and 2 add up to 90 degrees. But it also says angle 2 is congruent to angle 3. So what I'm going to do over here, I'm going to take a color and I'm going to mark this congruent statement here. So 2 is congruent to 3. So this tells me they are the same. So I can like start right there. Now what I want to get to is that angle 1 is a complement of angle 3. So before I write any of these things down, I mean, you can write given down, but before I do anything, I'm just going to kind of talk through it. So let's see, I can start with this. Then where would you, I'm going to come over here and sketch it. If I start with this, doesn't it, if I start with complementary, angle 1 is complementary to angle 2. If I start there, then what can I say about angle 1 plus angle 2? Come on, we just went over this.
They equal 90 degrees.
They equal 90. Okay, now once I get them equal to 90, then it's like, oh, well, what do I do next? What I really want is 1 plus 3 equal to 90, don't I? Because if I have 1 plus 3 equal to 90, then I can get that they're complements. How would I get 1 plus 3 equal to 90? Where would I go next? I know something else. What else do I know?
You know that angle 2 is congruent to angle 3?
So if 2 is equal to 3, what can I do next here? If 2 is equal to 3, what can I go here? Think back to algebra. If you knew that x was equal to 5, what could you do with 5 when you saw an x?
Angle 1 plus angle 3.
You see how you can do that? You can sort of substitute them because 2 is equal to 3. So if 2 is equal to 3, then you can just replace it. And now look, I have angle 1 plus angle 3 equals 90. What does that mean? That means that angle 1 is complementary to angle 3. Now you don't have to do this on every problem. This is an introduction to proofs. But I mentally do this every time I try a problem before I write anything down. I don't like to erase. I like to just like start and go a little slow and then figure out, oh, okay. So let's write our reasons. And this is the basic plan. So here's our reasons. So number one is going to be, as always, whatever you're given. And again, you can do abbreviations. So angle 1 is complementary to angle 2. And on the next line, if you have room, then just go ahead and put angle 2 congruent to angle 3 on the same line. But I didn't draw enough room. So that's number 1. And if I was on lined paper, of course, I would skip a line. So now I'm on number 2. Number 2, if I know that those are complementary, then I can say, oh shoot, I did forget one step. When I'm talking about numbers, I have to say the measurement. Sorry, I forgot about those. Okay, but that's okay, that's just my notes. So number 2, I can say, because they're complementary, that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Remember, when we put the M in front, that means numbers. But when it's the congruent sign, that means it's the shape. So this is a shape and this is a size. This is a picture of something and this is a number of something. So we have to do those separately. But basically, what it means is this is the definition of complementary angles. That's the definition of complementary angles. It means that we can add 2 angles together to get 90. So my next plan is to say that I can, if I know these are congruent, then I know that their measurements are congruent. So I need to say that the measure of angle 2 is equal to the measure of angle 3. And it's sort of like the definition of congruent angles, but I'm just going to put that equal if and only if congruent. I'm abbreviating, obviously, but what that means is that if 2 things are equal, then they're congruent, and if 2 things are congruent, then they're also equal. That's what that symbol means from last week. And so back to our plan, now that we know the measurements are equal, we can substitute. So we're going to do a step of, we're taking line 2 and we're going to rewrite it. But instead of a 2, now we're rewriting a 3. And that is simple substitution, property of equality. And our 5th and last step is that if I have angle 1 and angle 3 adding together to give me 90 degrees, then that means that angle 1 is complementary to angle 3 by the definition of complementary angles. So I may have gone a little quickly there, but once you figure out the path you're going to take, it doesn't take long to write them down. What you're going to need, but this is the plan. This is where you're going to get stuck a little bit. Like, how can I say that? So, but these reasons are really important. The good news is you're going to be using these all year and they will get more and more familiar to you the more we use them. So any questions before I go on to number 3? Just checking for hands. Okay. Okay. On number 3, if you printed it out, it didn't copy very well. So this is D right here, and this is E right here. So add that to your paper first. And then we're going to read. You reflect the beam of a spotlight off a mirror lying flat on a stage, as shown. So this is the mirror down here, and then here's the spotlight. Okay, great. Determine whether angle DBA, okay, so DBA is equal to the measurement of EBC. So we're actually not going to just determine this, we're going to prove it. So the first thing I'm going to do is highlight my angles, because they're not, like all these angles were separate, but here I'm going to highlight them. So I'm going to color this one pink. So I can clearly see that what I'm trying to show is that this angle here is equal, the measurement is equal to this one here. Doesn't have to be perfect, it doesn't have to be scribbled. But as I look at this diagram, remember how you get more information in your diagram about other things? Then here's another piece of information that I've gotten. These two little lines tell me that angle 1 is congruent to angle 3. So that gives me that right there. So angle 1 is congruent to angle 3. I get that right off the bat. I was given that information from the picture. Now, I'm going to look at this picture a little bit more. And let me ask you, can you see, how does this pink and purple relate? What do they have in common? Is there something that I could add to both sides or subtract from both sides to get them so that I could get this pink one equal to this purple one? What do you see? Just pipe up and tell me. The first few proofs are going to be like this, just sort of tedious and before you start thinking this way. Specifically look at angle 2.
Since angle 1 is congruent to angle 3, you could say that angle 1 plus angle 2 is congruent to angle 2 plus angle 3.
Yes, you can. So here's the big angle. Here's the big angle. See where they both overlap in angle 2? If you know that these two are equal, and this plus this equals this plus this, couldn't you like subtract angle 2 from both sides and then you get what you want? Or maybe you could add angle 2 to both sides and get what you want. And this is your job to just be staring at it going, yeah, okay, I can see how this works. Now, another thing you could do is you could start with this. Like, what if I started with this because it's in the picture, and then I just added angle 2 to both sides? I can do that, right? So I'm going to sketch this again, like talk my way through it. So if I had this, and then let's say I added angle 2 to both sides. I can do that with like the angle addition postulate. That says I can do that. Well, what are these angles? She just told me what they were. This one, 1 plus 2, is EBC. And this one here, 2 plus 3, is DBA. Wouldn't that sort of prove that those two are equal? So we have to write it up a little bit more formally, but I'm hoping that this makes sense to you. So we always start with what? A ruler. Always start with the ruler. Straight lines are our friends. So like I said, this is just sort of a plan to go on. It's nothing, it's not formal. Okay, so that's like a little sketch. All right, and here's our reasons. And we'll start with number 1, which is what we were given. And the only thing we were really given is angle 1 is equal to angle 3. Or angle 1 is congruent, excuse me. Both the size and the shape are the same. Now, here's another one of those very subtle differences. We don't say, this is like not official. If we want to use the angle addition postulate, we kind of really need to use the measurements. So this next step is sort of necessary, but it should not be, there's not really second nature yet. But you really need to go from the angles to the size of the angles. These are numbers and these numbers are equal. So that's that same symbol, you know, they're equal if and only if they're congruent, and they're congruent if and only if they're equal. But now we can add the measurement of angle 2. So we'll throw this in. So measurement of angle 1 plus measurement of angle 2 equals measurement of angle 3. Oh shoot, I thought I had enough room. Okay, I don't. But all we're doing is we're adding the same thing on both sides. So that's the additive property of equality. Skip a line. Now we need to state formally what the pink angle is and what the purple angle is before we can say they're equal. So on this next line, you're going to write 2 things. You're going to write, first of all, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle, so 1 plus 2 is EBC. And then you're going to say that the measure of angle 3 plus the measure of angle 2, because that's this side, 3 plus 2 is dBA. And this is actually what the angle addition postulate says, that you can add those together. Now I'm going to use my colors again, a little bit of a highlighter, and I'm just going to like point some things out. So for instance, this statement and this statement is the same. This statement and this statement is the same. So if you can follow those colors, this is why for the next one I can say, right, I can take this and put it here. I can take this and put it here, and I'm basically substituting. You can do it all in one step here. So it's going to be the measure of angle. I'm trying to keep them in the same order. I have 1 plus 2 first. So EBC, and then I have 3 plus 2, so then it's dBA, and that's the substitution property of equality. And then the last thing, if I did want to do one more step, now you don't technically have to, because that's really where we wanted to get to. But if you want it to exactly match what you're trying to show, you would technically have to swap these around. So it said DBA first and EBC last. I'm not going to be quite that picky, but some teachers are. So you need to be aware of it. I don't know how Big Ideas will make you do this on, you know, like in the book work, if I was grading it, it wouldn't affect you that much. But you know how Big Ideas sometimes will, it has to be exactly that way. So if you were going to add one more step, you would switch them with the symmetric property. Okay, but it's almost overkill. But again, you know you're done when your statement exactly matches what you are given up here to prove. So I would probably add it. Symmetric property of equality. And we have now done more examples. Now throughout this week, you're going to be watching a lot more examples. Hopefully you saw like 9 different examples yesterday. It was either 8 or 9 that I asked you to watch. Any more questions on these notes? Okay, so now that you officially have notes for 2.5 and you have a whole bunch of examples, I'm going to send you over to Big Ideas to practice some problems. Tomorrow we're going to be, going on to 2.6, but we can ask any questions on 2.5 if you like. I am going to make sure that Big Ideas has posted. So on our daily agenda, let's just make sure. Yeah, so we should be able to, I think we can go to Big Idea. Oh no, that's the Quizlet. Okay, so we have to go to, I have to go to my other window, which is, I guess I'll do my desktop. There we go. Where's Big Ideas? There's my portal, and there's Big Ideas. So just checking to make sure it popped up with the right times. Yeah. Okay, so it actually says due tomorrow by 3 o'clock. Get it done today if you can. I can see some of you already started. Great. Okay, so if you have any problems, let me know. But otherwise, it's 12 o'clock now, or 11:58. So you have 12 minutes to get started on it, and then yeah, tomorrow you're just going to be starting. So tomorrow's role is you'll have a little more time in class, and you'll start notes on 2.6. If there are any other questions. All right, since there's not, you are officially dismissed. And you can stay on camera, you can go, you can do as you wish, but you are now individually. Serato, stand up and get some air in your lungs. You're yawning. That means you need, some people have already dropped off. Okay, so yeah, I'll see you guys later, and
Thank you.
Thank
you're
you.
welcome. There, good.